You find yourself tumbling through space. Moments before, you were just on a routine spacewalk examining some minor cosmetic damage on your ship, when suddenly you started feeling strange. You felt a lurching in your stomach as your body started accelerating, and now you find yourself hurtling helplessly through deep space in the direction of the universe's most powerful, most mysterious killer, a black hole. You need to understand black holes, and fast. Here are 50 insane facts that may help. Fact 1. A black hole is a point in space that has such a strong gravitational pull that nothing can escape it, not even light. Our sense of sight relies heavily on either seeing the light emitted or reflected from the surface of objects. A black hole doesn't let that happen. Fact 2. The border at which light can no longer escape is known as the event horizon. Since light is the fastest thing in the universe, and it has the best chance of getting away, it's safe to say that anything else passing the event horizon will also end up tumbling in. Fact 3. Right now, you're hurtling toward the event horizon, going faster and faster. What'll happen if you go past it? Well, the process called spaghettification. And yes, that is its real name. Going feet first, the gravitational force affecting your feet will be stronger than it is at your head, meaning your toes will be stretched away from the rest of your body. At the same time, they'll be compressed together, forced into a tinier and tinier space, meaning that you'll be strung and stretched into a piece of human spaghetti for the black hole to slurp up. Delicious. Fact 4. If you look down, all you'll see is blackness as no light is rising up toward you from the black hole. But if you manage to crane your head just enough to look behind you on your way in, you'll be able to see where you have come from. That's because the light behind you is traveling in the same direction you are and at a greater speed, so the photons will still hit your eyes. Fact 5. Soon you'll pass the photon sphere, and things will start to look weird. Your window of the universe curves up and away from you, steadily shrinking smaller and smaller, giving you one last glimpse of your crewmates waving at you from the escaping ship. Fact 6. But that fate actually depends on the kind of black hole you're in. The spaghettification happens if you're falling into a stellar black hole. A supermassive black hole will be much stronger, but will treat you slightly better. That's because the stretching tidal force is less there. But bad luck, you're still not making it out. Or could you? To understand your chances at escape, you'll need to understand first black holes in a bit more detail. Fact 7. Since they're black, and space is also black, it took scientists a long time to realize they were even there. As far back as 1784, an astronomer by the name of John Mitchell theorized that such a thing could exist. He called them dark stars and thought that they were normal functioning suns like our own. His theory was that they were so big and heavy, 500 times the diameter of our sun, that the light particles would fly away out of them, gradually slow down, and be pulled straight back in by the force of gravity. Of course, his theory doesn't really hold water today, as we know that the speed of light is constant. You can't simply slow it down. And that light isn't a particle. Or is it? More on that later. For now, let's focus on the black holes themselves. Fact 8. Where do black holes come from? Well, let's start with a cloud of dust and gas, or a nebula. Loose matter floats around in space. Each particle has a tiny gravitational pull, and so they eventually start clumping together. The more it all clumps together, the more mass it has. The more mass it has, the stronger its gravitational pull, meaning more dust and gas. In the middle of things, the particles start colliding more and more. Each collision produces some heat. Keep this going long enough, and soon you're cooking with a main sequence star. The outward pressure of the nuclear fusion reactions in the middle balances out the gravitational forces pulling everything toward its core. And so this star is happy and healthy for billions of years. Our own sun is in the middle of this era, but all good things eventually come to an end. If the star is big enough, then eventually it'll no longer have enough energy to balance out the forces of its own gravity. It'll have one last giant explosion called a supernova and leave behind an incredibly dense core that collapses in on itself and forms a black hole. Fact 9. The core crushes itself smaller and smaller and smaller infinitely. The point of a black hole is infinitely dense and infinitely small. The core that was once as heavy as 10 of our suns crushes itself to be smaller than an atom, smaller than a nucleus, smaller than a proton, smaller than a quark, all the way down to a Planck length. But at that point, the universe hits its size limit. Quantum physics and our models of reality simply cannot compute anything beyond that point, as the wheels all fall off the carriage. We can't even know what happens with any certainty beyond that small of a point, since the concept of happens no longer even applies. Fact 10. If you want to understand just how small the Planck length really is, take a picture of a speck of dust by your window. Compare that speck of dust to the size of the Earth. It's tiny. But on a log scale, that speck of dust is the halfway point between the mass of the Earth and the mass of an atom. Fact 11. But the size of an atom is 100,000 times bigger than its nucleus. So if the atom was the size of the biggest NFL stadium in the US, the nucleus would be a marble in the middle of the field. So that's almost the size of a plank length, right? Fact 12. Nope. You need to go a quadrillion times smaller than that and then do the football stadium and marble trick again. If the whole Earth was the size of an atom, a Planck length would be smaller than a proton in the core of the Earth. Fact 13. So what's at the other end of the scale? If the singularity at the core of a black hole is compacting it down to be the smallest thing, what's the biggest thing? You guessed it, black holes. Fact 14. Black holes are measured in solar masses. In other words, that's the mass of our very own sun. This mass is 2 × 10 to the 30th kilograms. That's 2 with 30 zeros after it, or 2 nonillion kilograms. Fact 15. A black hole the size of Japan would weigh about 140 solar masses. That's 140 of our suns squashed to 0.001% of their usual size. Fact 16. We have a gap in our black hole size comparison chart, a big gap. Scientists have observed plenty of black holes around this size range in up to about 150 solar masses. The next ones up in size are millions of solar masses. Why aren't there any in between these two? Find out and you could win a Nobel Prize. Fact 17. What's worse than one black hole? 2. Since they are so massive, they tend to attract other equally massive bodies toward themselves, including other black holes. That's right, black holes can join together to be even bigger and badder. Fact 18. When 2 black holes join together, they release the most energy of any known phenomena in the universe besides the Big Bang. 2 massive bodies weighing the equivalent of a couple of million stars each, swirling around and around, getting closer and closer to each other, and sending incredibly powerful gravitational waves rippling through space in their wake. Fact 19. We all know that black holes can crush you, but do you think you could ever have a crush on a black hole? The iconic meme character Black Hole Chan is based on the personification of a black hole in the form of an anime girl, because certain parts of the internet are just like that. Specifically, she's based on the black hole in the center of Messier 87 galaxy, which became a generally huge meme in 2019 when a photo of it was successfully captured by NASA's Event Horizon telescope and released to the public. Fact 20. Black holes have a bit of a bad rep for sucking in stars and galaxies, but did you know that they can have an equally important role in creating them? According to a 2018 study, fragments loosed from black holes can sometimes create entirely new stars, and supermassive black holes sometimes play a part in determining how many stars a new galaxy has by influencing the process of star formation. According to the study, the smaller the black hole in the center of a galaxy, the sooner the process of star formation turns off, leading to smaller galaxies in turn. Fact 21. Sagittarius A is the black hole at the center of our galaxy. The Milky Way is much smaller than that in comparison. Its radius is only 17 times our Sun. It's tiny, and so our galaxy is fairly stable. Fact 22. So what's the biggest black hole ever? Well, the biggest we've found so far is Phoenix A. You can find it at the center of the Phoenix cluster, and don't worry, it's about 5.8 billion light-years away, so you won't be falling into it anytime soon. Fact 23. The previous record holder, TON 618, was pretty terrifying already, but Phoenix A is 1.5 times bigger than even that. Fact 24. The numbers get even more ridiculous. It weighs the same as 100 billion suns. Fact 25. You could fit the entire solar system into its diameter 50 times over. Fact 26. A photon of light that falls inside its event horizon would take well over a week to reach the singularity at its center. Fact 27. Scientists have had to come up with a new category for black holes to accommodate such gargantuan celestial bodies, ultra-massive black holes. Fact 28. But now Phoenix A has pushed for an even bigger category, stupendously large black holes, or slabs. Who says physics can't be fun? Fact 29. But Phoenix A is probably even bigger than we think. Since it is 5.5 billion light-years away, we're looking at an old version of it. Since the light has taken 5.8 billion years to reach us, that means it's already had an extra 5.8 billion years to grow, and right now, it'll be a good deal larger. Who knows how big the biggest black hole in the universe is right now? The best we can do is point our telescopes at the stars and look. Fact 30. That brings us to another question. How do you find a black hole? If they absorb all the light and are in the darkness of space, how do you see one? Well, you find a black hole by looking at its effects on gravity. Because they are so massive, they exert immense amounts of pull on the matter around them. Things start to act weirdly when they're next to a black hole. Fact 31. We often find them at the center of galaxies, and so you'd assume they are holding everything together, right? The Sun in our solar system is so heavy that it holds everything in orbit around it. In reality, most galaxies are instead held together by the forces of dark energy. Fact 32. One example of things getting weird is the Cygnus A black hole, which is 14 million suns in mass. It's surrounded by a spinning disk of matter in a fast accelerating orbit that is steadily being devoured beyond its event horizon. Matter is spinning around so quickly, in fact, that there are funnels of plasma shooting out of the top and bottom that are traveling close to the speed of light. Fact 33. While black holes are isolated interstellar events, there is a possibility that they could have created similar qualities across multiple instances. Deep radio imaging from astronomers in South Africa has revealed that many of the supermassive black holes in a particular region of space have radio jets that align the same way. Whether due to enormous electromagnetic fields or other primordial intergalactic forces, it seems as though the condition of the universe at the dawn of time played a role in this shared alignment. Either that or the black holes are communicating with each other and deciding to match, which, while fun to imagine, is not scientifically possible. Fact 34. Theoretically, if it was squeezed down to a size of only 3.7 miles or 6 kilometers across, our sun's mass would be compressed enough to become a black hole. In theory, this is actually true for any object, including your body. Thankfully, a means of causing that degree of compression isn't exactly within our grasp, so don't expect it to happen anytime soon. Fact 35. Some of the earliest black holes are believed to be appropriately named primordial black holes. The general consensus among scientists is that these black holes formed from the condensation of raw materials in the aftermath of the Big Bang, and most of these were far tinier than the majority of black holes currently at large in our universe today. Fact 36. There's been a lot of discussion about the masses of various black holes in this video. It wouldn't be unreasonable to wonder, how do scientists actually measure the mass of these things? The answer is simple in theory and incredibly complex in practice. They do it by studying the behavior of surrounding celestial bodies with incredibly powerful telescopes. Fact 37. We all end up in black holes eventually. One day, the universe will be made up of almost entirely black holes. Unlike a star, there's no big explosion at the end of a black hole. They keep on growing larger and larger as long as there's more mass to absorb. One theory about the way our universe could end is a big crunch. The Big Bang happened, everything expanded outward, but eventually gravity would pull it all back together again in one big crunch, theoretically triggering another Big Bang event. The current model is much more bleak. The expansion of our universe is not slowing down like it should be about now, it's accelerating. There's another force pushing it to get wider: dark energy. Fact 38. Dark energy is now believed to make up 69% of the universe's mass, and that dark energy is causing it to continue to expand. Fact 39. Regular matter, the stuff we're built from and everything we observe around us, makes up only 5% of the cosmos. Fact 40. In just a couple trillion years, the universe will have expanded so much that we won't be able to see our neighboring galaxies anymore. Stars will stop forming, and black holes will grow larger and larger as they swallow up all that's around them. Fact 41. Then we're into the big freeze. Black holes will dominate the universe, having absorbed virtually all of the matter and thermal energy around. The average temperature of the universe will sit just above absolute zero. Fact 42. So that's it then. Black holes will live on forever, and there will be nothing left. Well, not quite. You see, a black hole can actually die. Fact 43. In 1971, Stephen Hawking had an idea. He had spent years studying quantum mechanics. He was fascinated by the constant links between the smallest things in the universe and the largest. He believed that you simply couldn't understand black holes without quantum physics and vice versa. The two are inseparably linked. Hawking made a huge breakthrough that took decades to be proven, changing our model of how a black hole dies. Do you remember when we were told that nothing can escape a black hole? Well, that isn't quite true. Quantum mechanics has revealed that in the depths of space all the time, little particles flit in and out of existence. These are called virtual particles. They come in pairs, matter and antimatter. Since they have opposite charges, they almost always immediately crash into one another, canceling each other out. But next to a black hole, the gravity is so strong they actually get separated. One flies into the core of the black hole, the other flies off into space. Fact 44. Over time, black holes cool down. The particle from that pair falls into the black hole as negative energy, so it reduces its temperature by a teeny tiny amount. The one that gets away has managed to escape the clutches of the black hole with a teeny tiny amount of positive energy. This is called Hawking radiation. So just like a glass of water on a table eventually evaporates, so too does a black hole. Of course, this can only happen once they've fed on all the abundant matter around them and are left alone in a cold, dead universe. So there's your escape plan. It's simple. All you need to do is just spontaneously generate an antimatter version of yourself at the exact right moment, and negative you can fall to their death while positive you gets away scot-free. Well, sadly, no, you won't be escaping like that. So unless you have a pretty powerful rocket strapped to your back with near infinite fuel, it's probably too late. Fact 45. But you're in luck! There's no spaghettification happening to you here since you're falling into a supermassive black hole, and you're not being funneled into quite as small of a space just yet. As your crew watches you cross the event horizon, they see something weird. Your body is moving in super slow motion, suddenly pausing as you cross it. A still frame of you hangs in their vision, slowly fading away. No more light is able to reflect off your body, so the last instant where it could sticks around for a few moments as it slowly fades out, like a ghostly afterimage. Fact 46. Space and time inside the black hole stop behaving as you expect. Any direction that you try to move takes you closer to the center, even if it seems like the direction you had just come from. Fact 47. You're well on your way to becoming part of the singularity. Since it crushes everything down so small, there's no way of knowing that it was ever you who went into it. All information that we could ever hope to gather from a singularity is crushed out of existence. That means that if you switched off every black hole in the universe and compared the singularities side by side, you'd have no way of knowing which was which. From the biggest black hole to the smallest, they'd all be identical. Fact 48. Over time, the Hawking radiation will shrink the black hole further and further until eventually the singularity at the center will vanish from existence, giving off a burst of energy on its way out and leaving nothing. Fact 49. Except, of course, we are only humans and our brains are absolutely tiny relative to the scale of the universe. Our ability to understand these concepts is severely limited, especially since we can't exactly head over there to run an experiment. It's virtually all theoretical, and one of the big limitations we put on our models is that we almost always calculate for black holes that aren't spinning. Our models of singularities all hinge around a single point of infinite mass, but with black holes spinning at the speeds they do, that just wouldn't be accurate. The core would be spinning as well as forming a little ring or ringularity. Fact 50. If we can barely understand black holes that are stationary, we are a long way off from figuring out ringularity black holes. And herein lies your one last bit of hope. Under Einstein's laws of general relativity, anything passing through a ringularity is actually passing through a wormhole and will pop out of a white hole. This is the opposite of a black hole. Nothing can enter it and everything leaves it traveling faster than the speed of light. So, do these exist? They can't according to thermodynamics, but according to general relativity, they must. So, where do you end up when you've fallen into the core of a black hole? Do you now fly out of another black hole, but now traveling backward through time? Do you appear in another dimension altogether? Does this mark the Big Bang of another pocket universe hiding inside our own? Yeah, I don't know, your guess is as good as ours. It's just a shame you won't be there to see it, given you'll be very much dead by the time you get there. It was nice knowing you. Good luck.